up, everybody? We got it. Oh. All right, everybody, how we doing? Double time. All right. It's your captain speaking. Tonight, we're gonna get through part 5. We're gonna make the big push, and we're gonna get through it, guys. You hear me? Do you hear me, everybody? Because yesterday, after that 3D printer build, I was beat up. I was so tired. That was a 7-hour stream we did, all the way from point A to point B. That's my best captain speaking voice I got. This is your captain speaking. It's gonna be a rough ride, everybody. Alright, that's enough of Captain Joe. Let's get cereal here. Another good sound. A lot of that though. I still do that. Well, guys, I'm just trying to. Hold on, bogies. I don't know if it's picking it up for my mic. It might be picking it up for my actual speakers. I mean that I am. All right, enough fooling around here. All right, enough fooling around here. That's not bad. We can maintain that. All right, we can maintain that now. Just a little bit. We just bring it actually down small. About 36 decibels. That's not bad. We can maintain that. Right, we can maintain that now. Just a little bit. Yeah, we can just maintain that for now. And yeah, how's everybody doing tonight? So, yeah, today was the big day. Had the hiring event for the post office today. Hopefully I get the job, but still was slightly disappointed though. Slightly. I guess it wasn't what I expected it to be. And I guess that's just how life is sometimes, you know. I didn't, I guess, understand the position that I had applied for. It's more of a part-time type position with no benefits, which is kind of a bummer. You know what I'm saying? Because what I was looking for, I was obviously looking for benefits, for me and the kiddos and the wife and stuff like that. But I mean, I guess it's a foot in the door, you know, even though they kind of said it wasn't a foot in the door, but because I guess what the position, since it's like a rural carrier position, again, I didn't know what I was applying for. I was just applying to apply. I guess I'm just pretty much like a call boy if they need extra help, or if the guy the lady or guy who normally does the route can't do it, then I'm the guy who gets called in to do it for them. And I get no sick time, no vacation time, nothing. So again, it wasn't what it wasn't what I was expecting it to be. But I did ask, you know, what are the positions that do qualify for you know, for benefits and you know, a steady paycheck and whatnot. And that would be on the production floor, sorting the mail and stuff like that. So I want to be applying to those positions and stuff like that, and hopefully to land something on that. You know, but we're still going to maintain the cashier job, you know what I'm saying, the overnight cashier job and stuff like that, and see if I can maybe swing both at the same time. Yeah, I don't know. We'll see, guys. I'm, you know, again, kind of like disappointed, but it is what it is, you know what I'm saying? You know, if it turns out to I'm making a decent, you know, at least enough to suffice, you know, a living, we'll just have to figure out another way to get, you know, health care and whatnot after that. So, but yeah, it's cool. Enough of that. Let's talk about tonight. Tonight, I want to make the hard push because, again, after putting that 3D printed together yesterday, it like wiped me out for some reason. I don't know why. I don't know if it's because of my sleep schedule, and I kind of ignored my sleep schedule the last 2 days, just to do that epically long stream I did yesterday. Normally I would have slept all the way to about, you know, 3 o'clock-ish, just to be up for 5 to get everything ready and all that stuff. But you know, a couple days I had off, I just pretty much I reverted back to, you know, sleeping at night and then staying up during the day, and I think that kind of like messed me up. So yeah, so I just wanted to apologize to anybody that kind of hung out after the fact, after the 3D build, and I put everything back to normal, and I jumped on to chapter 15, and I was just wiped. But though, the neat thing though, what I ended, because I knew I wasn't going to be able to pay any mind to actually reading that chapter, so we jumped over to here I am, put me on it again, man. I don't know why. Again, I'm down in coffee and everything else. I must be like all over the place. Whatever, let's get pumped up, boys and girls. Let's get pumped up. But yeah, what I was saying is after though, once I figured out and I determined that my attention span wasn't going to be able to handle reading, we jumped over to Cisco Modeling Lab. And I tell you, I had actually a breakthrough. Even though, again, I was kind of like wiped out, I had a breakthrough with routing. We end up building a topology, a similar like topology. Here, we'll just go over it right now, so you guys can we can talk. We can talk about it. I got CML already booted up already, and I already got a router. So we're gonna be going through. I want to get through I want to get through part 5, so that is chapter 15, 16, 17, and 18. So I want to make a good hard push tonight. We'll see. I'm hoping. I got high hopes tonight, but again, I think I'm good to blast through these next couple parts and whatnot. So let's we can just take a gander at the the lab I built last night. Let's just go over that. If the music's too much, I'm gonna turn the music off here shortly, anyways. Just thought I'd add something to the background today. Just turn it down just a little bit more. Like 2 decibels. Let me just see how that sounds. Let me just see how that. Alright. That sounds pretty good. You can just barely hear it in the background. That's kind of how I want it to be. Some ambient noise. And if it gets too distracting, guys, just tell me and I'll turn it off. But once we start going through the chapter, obviously I'm gonna turn it off. Because there's no point of having it while I'm reading. So come on, Joe, get pumped up. Alright. Woo! Once you guys get me to affiliate, what we'll do, alright, and I'm shouting you guys out, let's get me to affiliate, alright? Because once we get to affiliate, one of the things will be Joe's gonna do some push-ups. You guys are gonna get me back in shape by getting me to affiliate. So if you want to get Joe into shape, get me to affiliate, and then you guys will I'll make some prompt commands to make Joe do some push-ups, some sit-ups, and stuff like that. Like my drill sergeants used to, some flutter kicks too, like my drill sergeants used to do to me back in basic training. Because I was the guy that was always falling asleep during class in basic training. That's why my chest got so big, because I was always doing push-ups in basic training. Ooh, ooh. I remember doing the PT test. I was, I gotta get this over there so I can actually see what the heck's going on. I remember doing the PT test. I was the guy that was always so confident with my push-ups because I could always do so many push-ups because like I said, during basic training, I was the push-up king. But whatever. So this lab right here, guys, what Epic Pen. Where did you go? Where did you go, Epic Pen? There you are. I swear, Epic Pen. Ever since they did this crazy update, Epic Pen, you got to fix this, my boy. My boy. Aggravating me. Oh, why is that? Oh, it sticks to cloud. That's always. My boy Epic Pens. If you guys work for Epic Pen, you guys are watching me. Come on, we need another update. I might just skip my shout out. I love Epic Pen, but again, ever since this update they did. All right. So, what we got here, obviously, you can see right here, we got a little, I call it a little distro type router. And I guess after we get through all this, we'll boot this lab up. But I already have another router on another lab opened up, well, running right now, so we don't have to waste time waiting for that thing to boot up. Come on, man. All right. So what I kind of did is I made 4 total separate areas, okay? All right, as you can tell here. All right, now each area had their own, had their actual own IP address range. I believe this one was 192.168.0.1, and this one was, I think, 10.0.0.0, and this one was 172, something like this. I had configured, and guys, 31.0.0. So as you can tell, each one had their own little IP range. This little distro router, he was 5.0.0.0. And then what I did with the links is I gave them, I put them all in the 5 network. You know what I'm saying? I'm just gonna, just for instance, give you guys a couple I know it probably don't make no sense, but this is how I kind of IP addressed all the links and whatnot. Don't pay too much mind to what I'm scribbling on here. I'm just giving you a for instance. All right, we can take a look at it later. But what I did was I had this distro router. Again, I had it act as like an ISP, like an internet service provider router in a sort of kind of way, where it was like, say these areas had purchased my internet service, okay, quote unquote, they purchased my internet service, and then I gave them one of my routers, like say Comcast, Verizon, or whoever else you guys have as an internet service provider. Okay, so you guys are buying my internet, here's my router, here's my service, and they plug in their router, and then they get an IP address. Okay, I have an IP address, and I give that to them, and that, in that information packet that I give to them, it also has default gateways and everything else. So this distro router, what it did is when these links came on, I had them hook up to DHCP, and they got dynamically addressed within my ISP's. I guess it wasn't in their range because I also had them in different subnets too. You know what I'm saying? But they were in the same area. How's that? All right. So all the links between the routes were in the same area. Okay. So all these links, all right, they all came back to area 0. Okay. Man, I write like a 2-year-old. So they all came back to area 0. So all these links here, they all belong to area 0. All right. But what these routers though, these routers had their own, they were responsible for their own areas. Okay. All right. So even though these links all belong to area 0, each router though had their own quote unquote area, okay? Because each area was separate from one another. But they are all connected to the same backbone area, okay? I guess if that makes sense. What I was kind of what I was trying to do and trying to lab up was multi-zone, how to routing between multiple zones via OSPF and having everything work. And it worked great. And it was surprising because how simple the actual configuration was. So like in this one in the Texas area, I think I gave it like area 10. So this was area 10, this was area 20, this was area 30, this was area 40. And I didn't have to static any of that information in the distro router. I didn't have to static that into anything else. All I did is on the interface that serviced the area of that actual router, I just told the interface, okay, so interface that has the, we'll say for instance the 1962 network, okay, interface that has this network, you are gonna be you are gonna be area 10, but you're gonna pretty much tell OSPF that off this interface I have an area 10. So it was pretty much I OSPF area it was like what's the word I'm looking for? It was what's the word I'm looking for? Advertising. That's the word I'm looking for. It was like, okay, I want you to advertise that off of this interface, there's an area 10, all right, and it belongs to that IP address range. Okay, same thing with the Colorado router. So off of this interface, I want you to advertise that there's this network. Same thing here. And same thing here, all right? Again, I didn't static anything, and I didn't, per se, go into the distro router and build multiple areas. All I did was I told those interfaces to say, okay, I have this route. I have this network off of this interface, and now I should advertise it out. And it worked perfectly. It worked perfectly. All these routers, including my distro router, all picked up the information, okay? And they were able, all these PCs and all these routers were able to communicate and route packets correctly to everything. It was pretty neat. It was pretty neat because it was something I hadn't labbed up before. And it was, I guess it was it's how you build stub areas in OSPF. I went through I have the CCMP and the CCIE Enterprise Core Advanced Routing book here, and that's where I don't want to say verbatim because the way they had theirs was a little bit more complicated than I per se. Like, let me see this second OSPF. So the way they kind of had their configuration of multi-area OSPF, let me see what they did that I didn't do. They actually staticked some routes into the the main quote unquote router. You know what I'm saying? Where I didn't have to static anything. And I wonder why they did that. I think they just did that just to show you, you still can do it. I still need to. Obviously, I'm not on the CCNP level because I'm still on the CCNA level yet. But I just wanted to. Yeah, they did again. Yeah. And that's and I didn't. I guess I didn't call it stub. I just called it area, and I didn't identify it as being a stub. So it was just advertising it as an actual area. But yeah, I guess we could take a look at it later. But no, it was. I guess for me it was just really neat to get working, just because it had that was something I haven't tried to lab or try to figure out yet. So again, I was struggling to get through the reading portion of the studies yesterday, but I felt as though I made a good breakthrough though on just labbing. So I got just a simple router up today. Again, we're getting back into, we're just going to be diving into routing, just basic routing fundamentals and operating system routers and whatnot. So we're going to be just talking about that as we go along. We'll go back through. Again, this is just going over some of the actual the fundamentals of what a router does. I guess because we've been learning so much about layer 2 switches and whatnot. We really haven't talked about routers and the differences between routers and whatnot. So we're gonna take a good hard look at that today, and yeah, I guess we just get started. Let me kill the music, and we'll go from there. Kill that now. Let me crack my window. Maybe some cold air will make me feel a little bit better. I still haven't figured out the 3D printer yet, though, guys. That's that's something that's further. Do some stretches. Ooh, let me stand. All right. I don't know if I should stand or sit down. I don't know which will be better for me to get through this tonight. So, all right, let's make a good push. Let's make the big push. All right. Seltzer water time. I am working tonight though, but we'll get to that. All right. All right. So operating Cisco routers. Again, we talked about this yesterday. Explain the roles, functions, and network components. Routers describe characteristics of network topology architect. Small office, home office, Soho networks. Configuring and verify IPv4 addressing and subnetting. We're gonna get. That's why I got that router up so we can do some of that stuff. You know what I should do? Instead of using this, actually, we'll cancel that. And we'll do this. Let me boot this bad Larry up. You know what? We're gonna do this together, guys. We're gonna do this at the same. We're gonna be working with CML and everything else all at the same time, guys. Might as well. Might as well. That way, we can I can kind of keep things alive tonight. No, 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 no. Let's see. One. Two. Let's see. Two. 30-1. And we've got C 30-2. What do we got for examples here? So I got that for now. Let's take a look at some of what we got for examples. Let's do this. Switch. That's right. That's those are up. Two. We're gonna call you. What should we call you? Call you. Let's see what the book says. We'll call you plot one. Two. C one. I hate when it does that. C 1. C 100. No. Take a minute. Trace back, trace back, trace back. Love them trace back.
All right, let's call this. Call you 0. Zero, F2. All right, so this would be our backbone type area. Separate areas, and then everything else after that. Yeah. Good. Something on now. Let's see. These guys on now. Let those boot up. All right. Well, those booting up. Let's get started on our chapter review here. All right. Getting an IPv4 network up and running requires some basic steps. Installing routers, which we just did. We installed our routers, okay? Installing cables. We haven't done any cabling yet. Ordering the WAN service. So we're going to be ordering the WAN service from our area 0 here, all right? The installation also requires some routing configurations because routers often use defaults so that the router does not require IP packets, does not route IP packets until configurations have been made. You will need to configure IPv4 address and enable interfaces at an IP route, either through static configuration or by enabling some dynamic routing protocol. This chapter focuses on the first steps. The first steps to creating a small working network. I will show enterprise class Cisco routers and configure interfaces and IP addresses. This chapter breaks the topic into two major headings. First discussion, the physical installation of the enterprise routers. Second section looks at the command line interface on Cisco routers, which has the same look and feel as Cisco switches command line interface. The first list similarities between switches and routers command line interface, and then introduces the configuration requires to make routing stop forwarding packets. Right. So again, we stepped up to the layer 3 in the OSI model, the OSI steps there. Okay. We're into packets, the forwarded IP packets. Okay, that's what we do. We're in the IP. Now we're routing packets. Okay, and it's different than I guess it's different how switches forward frames. Okay, we're not forwarding frames. We're routing packets with a router. Okay, all right, all right. All right, which of the following installation steps require a Cisco router, but which of the following steps are more likely required on a Cisco router, but typically not required on a Cisco switch? We'll do these real quick. These I got wrong yesterday. Let's see if I can remember. So one is B and E. I guess you don't turn off the switch. Okay. I'll make that bigger. All right. Which are the following? I guess because if you're thinking layer 2 switch, you can just plug that thing in. It's almost like a hub where it just starts going to town. Which of the following commands might you see associated with the router command line interface, but not with a Cisco switch. Now remember, this is talking about layer 2 specifically, and it should mention that instead of just saying switch, but it's talking about layer 2 specifically, switches. So we want to see the show IP route command, and the show it's only looking for one, so it'd be B. 2 B. I think I picked like 2 yesterday or something like that. Kind of crazy because again I wasn't paying attention to what I was doing. All right. Which answers list a task that could be helpful in making a router's interface gigabit 0-0 ready to route packets. All right. You can choose 2 answers. Now we got to choose 2 answers. Okay. So configuring the IP address mask command. Configure the IP address. Configuring the IP address or IP address mask command on the configuration. Yep. And configuring the no shutdown command. Yep. So A and C. So 3 A and C. All right. The output of the show interface brief command on router R1 lists the on the interface shows the status code down and down for instance gigabit 0-0. The interface contents connects to the LAN, connects to a local area network switch with the UDP straight through cable. Which of the followings would be true? Shutdown command is currently configured on the router's gigabit 0. Probably. The router has never been configured with an IP address. Oh. Down and down. I'm going to say C. It hasn't been configured with a IP address yet. All right, which of the following commands do not list the IP address in mask as of at least one interface? Which of the following commands do not list the IP address and mask of at least one interface? So choose 2 answers. So we're going to say show version and show protocol. So let's choose B and E. All right. Which of the following is different on a Cisco switch command line interface for a layer 2 switch compared with a Cisco router? The command used to configure a simple password by checking the number of IP addresses configured, the configuration of the device's host name, the configuration of the init. So let's go with B. Not B and H. There's not even an H option. All right. Let's see how we did here today. Hopefully we did better than yesterday. B and E, good. B, good. 3, good. All right. Oh, we got one wrong. And B. All right. Let's take a look at what we got wrong. Clear that off. So, show interface. Oh, all right. Show interface brief. And it is right because it won't show the IP addresses. So. Very, very good. All right, I need to make a request for more coffee. I don't know if it's these lights that does this to me, guys. I don't know why. But I'll be right back. Hold on. Hey, can you holler at me real quick? That's fine, but get some more coffee in me. Got some coffee starter at least. All right, so we kind of breezed through that. Let's go check out Cisco Modern Lab real quick. All right, these are booted up. Well, the consoles. No. That do its initializing. Do one at a time on these ones. Break anything here. Like I said, we're gonna be going back and forth to CML and this at the same time. So again, I want us to make sure we're putting in the lab time, because I feel as though labbing this is just as important as doing it at the same time, at least during this part of the chapter, right? At least part of the book, at least. All right, we'll do one at a time. All right, installing Cisco router. Routers collectively provide the main feature of the network layer. So network layer 3, okay? The compatibility to forward packets end to end through a network. As introduced in chapter 3, fundamentals of WANs and IP routing, forward packets by connecting to various physical network links, like Ethernet LAN, Ethernet WAN, and serial links. Then using the layer 3 routing logic to choose where to forward packets. Each packet. As a reminder, chapter 2, fundamentals of Ethernet LAN, covered the details of making those physical connections. The Ethernet networks, while chapter 3 covered the basics of cabling with WAN links, this section examines some of the details of routers, installations, and cablings. First, from the enterprise perspective, and then to the perspective of connecting a typical SOHO to an ISP using high-speed internet. Okay, so that's what that lab was yesterday. It's like all those enterprise or SOHO networks connecting to the ISP, and then obviously when you connect to the ISP, they already have their routes and everything configured into that packet that they're gonna send you to that router. So that router can do. It's almost like they're gonna automatically configure that router. At least that's what it's like for at-home routers. You know what I'm saying? All right. A typical enterprise network has a few centralized sites, as well as a lot of small remotes. So that's what it was kind of like depicting. To support devices in each site, the computers, IP phones, printers, other devices. The network includes at least one LAN switch at each site. In addition, so that's the we're gonna say the quote unquote distro switches there. Each site has a router which connects to the LAN. In addition, each site has a router which connects to the LAN switch to some WAN link. The WAN provides connectivity from each remote site back to the central site and to the other sites through the connection of the central site. So that's what we kind of did with that distro switch, and kind of like what we're going to be building off of today. So I'll show a couple different kinds of network diagrams that might use represent enterprise network. The style of the figure supports a discussion about layer 3 topics, showing the subnet mask and interface IPs in shorthand. The figure also keeps the physical and data link details to a minimum with these conversations. Okay, so Ethernet LAN, a simple straight through line with some or more LAN switch implies but not shown. Ethernet WAN shows it as a straight through line. Ethernet WAN shows a straight line, often with a cloud over it, with some kind of Ethernet interface shown by the router. In this case, the gigabit 0-1-0 and the gigabit 0-0, which refers to gigabit interface. All right, where are those? Okay, so that's what this is representing right there. Man, come on, buddy. You can do it. You can do it. Man, I don't know if I'm stretching myself out too much doing all this stuff, but we're gonna push. All right. Serial WAN. A LAN with the crooked line. So this crooked line right here in the middle, like quote unquote lightning bolt. All right. Represents a typical type serial point. So that's what this is going over. Okay. So Ethernet LAN shows a simple straight through cabling. So straight through cabling. Kind of what this is representing right here. This is representing Ethernet WAN. So Ethernet LAN, local area network. So local area network, okay? Ethernet local area networks. So these are the networks off of the 172.16.1.0-4, 172.16.2.0, 172.16.3, okay? These are the local area networks, okay? Ethernet WAN shows a straight line, okay? All right, often with a cloud in it. Okay, so this is representing Ethernet WAN, Ethernet wide area networks. Okay, so sort of like what some of us are using right now. I want to say all of us. Some of us are still, our ISPs are still using serial links. So that's what this lightning bolts represent. It's a serial link. Okay, so that's a serial wide area network. Okay, instead of the Ethernet wide area network. Okay, all right. Come on. I think I need to pick me up. Right. I need to get a push-up camera for you guys so you guys can see me start doing push-ups when I feel tired again. So let's do some push-ups. It's going to be part of the stream now, guys. You'll get back into shape again. All right. Woo. Did some pushy ups. Get my muscles back. Ooh. Used to be a bodybuilder, guys. Used to be. Not anymore. Well, we're gonna get back. We're gonna get back in shape. Okay. Woo. All right. I swear, every time now I feel tired, I'm gonna start doing push-ups and flutter kicks, some other stuff. I need to wake up. All right. Come on. Woo. Big marker. No. Okay. All right. So we get that. Let's go back and go to CML. That's good. Let's say no. Let that do its thing. Let that do its initializing real quick. And we only got to boot up this last switchy switch here. And all of our stuff's going. All of our stuff should be up. Okay. Let's push on. All right. A generic enterprise network diagram. All right. So we have our central site and we have some of our branch sites. Central site, obviously, that's the site. It's like, it's got all of its, you got, you know, your DHCP servers, your DNS servers. You probably got a web page server sitting at your central site. That's where like the company's web page, quote unquote web page, is probably sitting on. And probably all, you know, you have a DNS server that's doing all of the the DNS services inside of your company. You know what I'm saying? This is just showing that serial. Let's kind of make that smaller. Here's showing a serial cable. So this would be, holy guacamole, to a big man. So this is showing, that would be like the lightning bolt lease line. I think that would be, that's different because, woo, I'm like scribbling on the board over here. I believe a lease line is different, would be represented different. or I think it might be represented the same as a serial or different than a serial. Um, hmm, A lease line could be an Ethernet line too. Well, that's the discussion that we'll have to see if it gets into later. But like I said, so this is obviously again central site. So probably a lot of the services from these servers are probably still going through and being routed through all of the serial lines, lease lines, through the routers to the branch sites, and probably doing some services for these PCs over here. You know what I'm saying? These PCs over here are probably getting DHCP, DNS, all from these servers sitting at your central site. All right. They're probably there's probably even some more services going on too. You know what I'm saying? But that's kind of where this thought process is going right now. Okay. All right. All right. Look at that. All right. So we're up. Now we just have to get this one more switch up and going, and then CML will be ready to rock and roll by the time we get over there. So, all right, more detailed cabling diagrams for the same enterprise networks. Next, consider the hardware on the ends of the serial links, in particular for the channel services unit, unit or data services. Yep. So we have the CSUs and the DSUs. So channel service units and then data service units. So let's say that again: CSU channel service unit, DSU data service unit. Okay. That's, I guess, some of the hardware that's sitting at each ends of the serial links. Okay, hardware resides on each end of the serial links. In a rail serial link that runs through the service provider, the link terminates. The link terminates at the CSU DSU, so the channel service unit and the data service unit. All right, I'm gonna put my camera down there so you guys can see me do push-ups and flutter kicks and torture myself today. I'm gonna torture myself for you guys today. Here, this will be the push-up camera now. It's gonna be the push-up camera. Push-up camera time. This ought to be fun. So let me see how that looks real quick. You're gonna see a floor real quick, but it's gonna be the push-up camera. Oh, that looks horrible. But we're gonna go. Let's go to. Where do I have? Right here. Okay, so that'll be. So when we do push-ups. Okay, so let's do some push-ups real quick for you guys. Let's see. Here we go. All right. So this is the push-up camera, guys. Push-up camera. Ooh. 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoa. Okay. Push-up camera. Push-up camera. All right. That's the push-up camera. Stop looking at my crotch, guys. You sickos. What's wrong with these? All right. Push-up camera. This ought to be fun. I'll move it over here. All right. We're going to be doing push-ups and other stuff today, guys. Kind of get me pumped up. You guys got to get me pumped up. You guys got to get me to affiliate. I'm telling you guys. Hurry up, guys. Get me to affiliate. Let me add another box here. Hold on. I got a small little box. Ooh, I do. give this some perspective a little bit over here. So it'll be fun today. All right. There we go. Yeah. All right. So that looks now. Oh, it's a beautiful thing, guys. It's a beautiful thing. All right, let's do some flutter kicks now. Flutter kick time. Flutter kicks. Let me see how that looks, huh? Oh yeah, it's great. All right, flutter kick time. Ready? 1, 2, 3. Oh, I need to go higher. All right. Flutter kicks. You guys are gonna get a workout session with me. All right. Ooh. All right. Wake up. Wake up. Wake up time. All right, we're good. All right, let's get back to it. It's probably gonna do horrible things for my back. It's gonna be good. You got coffee? You're the best. Look at that. I love me daughter. Me daughter loves me. All right. Thank you, baby. All right, we got some more coffee. Looks a little weird. I'm gonna drink it anyways. What she did to it. Whatever, it's coffee. I think. I hope it's coffee. Woo! Alright, I'm fired up now. See what I'm saying? That's all I need to do. Do some push-ups, some sit-ups, and we're good. Alright? Alright. Fire it up, guys. Fire it up. Alright. Alright, in the rail serial links that run through service providers, the links terminates at the alright, so the links terminate at the CSU and the DSUs. The CSUs and DSUs can either sit outside of the router separate from the device as shown here. So here's the CSU, DSU. Alright. The router serial ports have the RJ4048 port to each serial that should cable that should connect with an external CSU DSU. The CSU DSU must be connected to the router's serial card via a short serial cable. Okay, so that's what this kind of represents. All right. All right. Cool. Cisco integrated service routers. Product vendors, including Cisco, typically provide several different types of router hardware. Today, routers often do much more work than simply routing packets. In fact, they serve as a device or platform. That's actually what Cisco's calling their new routers. Is they're calling them platforms. And I believe that's because they're more than just switches / routers now. They're almost, I believe their new product it's like the cloud service router, where it's almost like a Linux-based operating system running Cisco iOS, but in like a beefier way. That's doing switching and all these other things all at the same time while providing other services integrated into it. I guess they're acting, you can have them act as autonomous units all on their own and stuff like that. So they're calling their new routers, quote unquote routers, platforms now. So that was another thing that that David brought up too in one of his other videos. No, I do not want to become famous, man. Alright. Taking care of that message, yeah? Alright, clear that up real quick. Why is it still showing up in the thingy? This friggin' spam messages, dude. I'm getting sick of those. I gotta figure out. I just gotta like copy that message and like have Nightbot take care of the stinking thing. All right. Oh, we might have to do some more push-ups. Okay. Where was I reading? Simple fact that these. All right. So these serve as devices or platforms from which to provide many network services. Cisco even brands its enterprise router not just as a router, but as an integrated service router. So integrated service routers. That's a big word right there, guys, okay? Because it's doing multiple services, not just routing packets anymore. These routers are doing multiple services, okay? So that's why I think they're calling them platforms now, okay? Emphasizing the multiple purpose nature of this product, okay? As an example, consider the network functions needed at a typical branch. A typical enterprise branch office needs a router for wide area network and local area network connectivity. A local area network switch to provide high performance local network and connectivity into the router and into the WAN. Many branches also need voice over IP services to support IP phones and several security services as well. Plus, it is hard to imagine at a site with users that does not have Wi-Fi access today. Okay, so rather than requiring multiple separate devices at one site, as shown in the figure, Cisco offers a single device that acts as both router, switch, and provides all other functions as well. For the sake of learning and understanding different functions, this book focuses on using separate switch and separate routers, which provide a much clearer path of learning the basics. Okay, shown in the figure, a photo of a Cisco 4321 ISR. With some more important features highlighted, the top part of the figure shows a full view of the back of the router. This model comes with two built-in gigabit Ethernet interfaces and two module slots that allow you to add small cards called network interface modules. All right, NIMs, network interface modules. The bottom of the figure shows an example of a NIM that provides two serial. All right, so there's two serial interfaces. There's the little serial ports right here. This is the NIM that it's talking about. The router also had other items as well, include both RJ45 and USB console hookups. So here's some of our RJ45 hookups. All right, and then some of our USBs. Here's our gigabit interfaces right here. All right, and here's that on and off switch. All right. This is, I guess, the slots for the serial interfaces right there. So that'll go into these two areas. These plates can be removed. All right. Yep. All right. So yep, that's that. That's that. Looks good. All right. Let's keep it moving. The figure shows an important feature for using routers to connect to both Ethernet LAN and Ethernet WAN services. Look closely at the figure. The gigabit interfaces. Gigabit 0-1 refers to the interface in the gigabit Ethernet 0-1 and the RJ45 port that supports UDP cabling only. Okay. However, the interface gigabit 0-0 short for gigabit 0-0 has some interesting features. The router has two. All right. So what is it stating here? So the figure shows some important features of using both a router. Look closely at the figure. Gigabit interface, gigabit 0-1 refers to the interface. Gigabit 0-1 and the RJ45 that supports UDP cabling only. However, interface gigabit 0-0 has some interesting features. The router has two ports for. All right, so that's what this represents. So that these two ports represent gigabit 0-0. And that one just solely represents gigabit Ethernet 0-1 on that one, okay? You can use one or the other at the point in time, but not both. One physical port is a RJ45 that supports copper cabling, implying that it is used to connect to LANs. The other gigabit 0-1 physical port is a small form pluggable SFP port that supports various fiber Ethernet standards, allowing the port to be used for Ethernet WAN purposes. Okay, all right. Cisco commonly makes one or more of the Ethernet ports on its enterprise class routers to support small form factor pluggables. So let's remember what that means. SFP, small form factor pluggables. Okay, all right. So that the engineers can choose an SFP that supports the type of Ethernet cabling provided by the Ethernet WAN service provider. Okay, so if you have if your ISP is providing you with fiber optic type services, then you would use the gigabit 0-0 port as that port that you would hook up to your wide area network. Okay, so that's what this port right here would be used for. Okay, to be used for that purposes. But then you could not use its physical port. You couldn't use its Ethernet port, its UDP port. How's that? All right, you can use its UDP port as a port. All right, because you're already using it as for the wide area network fiber optic. All right, the small form pluggable. All right, but you still have available the gigabit 0-1. Okay, all right. So obviously with a router like this, you would need obviously a switch, so you could have it service your LAN, your local area network there. Okay, but then obviously you have your ports, your NIM slots. So your NIM slots, you have multiple NIM slots here, so you have access if you had a serial links going into that router. Okay, this doesn't taste like coffee. Doesn't smell like coffee either. I don't know what you did. Whatever, we're gonna drink it anyways. Might have got out of the toilet. Who knows? It's warm anyways. All right. Let's keep it moving. When building a lab network to study for CCNA, CCNP, because your devices will be in the same place, you can create Ethernet WAN links using RJ45 ports and UDP cablings without the need to purchase some SFP for your router. So it's just stating that there is, while labbing it up, there isn't really no difference with using small form pluggable or fiber optic type cabling for your lab purposes. Okay, it's generally the same. It'd be the same as using UDP cabling. Okay. All right. Physical installation. Armed with the cabling details. Right. Armed with the cabling details. In the image. In the router's hardware details in the photo, you can physically install a router. To install a router, follow these steps. All right. For any Ethernet LAN interface, connect the RJ45 connectors of the appropriate copper Ethernet cable between the RJ45 ports on the router and one to the local area LAN switch. Okay. For any serial WAN ports, if you're using channel support, channel service units or data service units. Channel service units or data, that's the term, right? Channel service and data service. Let's just take another look. Just want to make sure I have my terminology right. Channel service units, data service units. Okay. All right. If you're using external data channel service units or data service units, connect the router serial interface to the channel service unit / data service unit and the channel service unit / data service unit to the line to the telco. Telco would be the telephone company line, so the line that you're getting from your ISP. Okay. That's all that telco is representing. Okay. If you're using internal data service units, channel service units. Connect the router serial interface to the line from the telco. Okay. For any Ethernet WAN ports, when ordering the Ethernet WAN service, confirm the required Ethernet standard in the S small form pluggable type required to connect to the link. In order the small form pluggables. Yep. Install the small form pluggables into the router and connect the Ethernet cable from the Ethernet WAN link to the small form pluggable on each end of the link. Connect to the router's console port to the PC as discussed in chapter 4. All right, as needed to configure the router. Connect the power cable from the power outlet to the power port of the router. Power on the router. Note that Cisco enterprise routers typically have an on and off switch, while switches do not. That's what I got wrong earlier. I just assumed switches had an on and off cable. An on and off plug. I guess they don't. We just learned something. They do not have a plug. So, all right. So there we go. All right. Let's do some more push-ups. Sergeant Casper. Let's do some more push-ups, Sergeant Casper. Sergeant Casper, if you're up there right now, here's some push-ups for you, buddy. Let's do some more push-ups. These are for Sergeant Casper. Only Sergeant Casper gets to get the shout-out while we're doing these push-ups, okay? Nobody else, only Sergeant Casper, all right? These are for you, Sergeant Casper, all right? Sergeant Casper, I can't afford big diamonds, so I'm going to have to do small diamonds, Sergeant Casper. All right, until I get a little bit richer. All right. Ooh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it goes. Some small diamonds. All right, enough of that. Let's get back to it. Woo! You fire me up. You fire me up, Sergeant Casper. All right. I'm a hot potato today. You're a hot potato, Joe. You're a hot potato. All right. Installing Soho routers. The term enterprise routers and Soho office routers act as a pair of contracting categories for routers, both in the terms of how vendors like Cisco provide to the market and how enterprises use and configure those devices. The term enterprise router is typically referred to a router that a company would use in a permanent business location, while SOHO routers would reside at an employee's home or at a small permanent site with just a few people. However, as you might guess, the lines between a router's acting as an enterprise router and the SOHO router is blurry. So use these terms as general categories. Okay. Even with that general comprehension, SOHO routers typically have two features that in an enterprise routers would be less likely to have. SOHO routers almost always use the internet and virtual private networks, VPN. So SOHO routers almost always use the internet and virtual private networks, VPN technologies, for their WAN connections to send back and forth to the rest of the enterprise. SOHO routers almost always use multifunction devices that does routing, LAN switching, VPN, wireless, and maybe some other features. So SOHO routers do a lot of services, okay? All right? So they're talking about VPNs, they're talking about Wi-Fi, they're talking about, probably some even other services, DHCP, probably some DNS. Throw some DNS up in there too, all right? Up in the mix. Woo! Getting pumped up. Get my pump on. Check out these biceps. Wah! They're not as big as they used to be. All right. For instance, at the enterprise business location, the building may contain. For instance, at the enterprise building location, the building may contain enterprise routers, separate Ethernet switches, and separate wireless access points. So they're just explaining that at the enterprise level. They're breaking up all these technologies, okay? So they're only doing it on their own, okay? All right. All connected together at permanent business sites with 4 employees and 10 total devices in the network. One SOHO router could provide all those same features in one device, okay? For instance, in the figure, shows a typical SOHO site with 3 icons that represent a router, switch, and access point, actually all existing in one box. Okay, the figure just shows them separated to emphasize the fact that one SOHO router provides several functions. On the left, the SOHO router provides wireless and wireless LAN servers, and on the right, it provides wide area network access through the cable to the internet connection. Okay, so this right here. So what it's saying is this is a representation. So this box right here, this would be figuratively and physically all in one actual SOHO router. So we have access points that's giving Wi-Fi signals. So those radio waves that you're getting for your Wi-Fi and stuff like that, that's coming from that SOHO router. Switching. All right. So you'll have, instead of just having that one port and then needing another switch, your SOHO router usually comes with multiple. You'll if you look on the back of it, it usually has multiple ports on it. Okay, so it's acting as a switch as well. Okay, and then obviously it's acting as a router too. Okay. All right, let's keep it moving. Woo! More push-up time. Don't worry. All right. The figure. All right. So yep. So figure the next figure does not reflect the physical reality of the SOHO router. So the figure shows one cabling as example. The figure shows user devices on the left connecting to the router via wireless or via Ethernet UDP cabling. On the right, in this case, the router uses an external cable modem to connect to the coaxial cable provided by the ISP. Then the router must use a normal UDP cabling port to connect to the short Ethernet cabling between the SOHO router and the cable modem. Okay, so that's what it says. Pretty much just going over is in a SOHO, for instance, it's connecting via via a UDP cabling to the ISB's modem. Obviously, then the ISB's is using some kind of coaxial type cable off to the big world of the internet. Okay, and then it's just by these squiggly lines showing Wi-Fi, and then more UDP cabling. That's the Soho router doing multiple functions with it, acting as an access point and a switch and a router all at the same time. Okay. All right. Moving now. All right. Enabling IPv4 support on a Cisco router's interface. Routers support a relatively large number of features with a large number of configurations in the exec command. To support those features, you'll learn about many of these features through the rest of the book. For perspective, the Cisco router documentation includes a command reference with a index in every single router command. As a quick informal count, as of the recent iOS version listed, it has over or around 5,000 commands in the CLI. All right, so 5,000 commands. That's a lot of different configurations. Woo! What's going on, my muffin? All right, taking my... Oh, are you really? On the 7th? Have you been studying? Where are you at with your studies, my friend? On the 7th, dude, that's next week, brother or sister. That is next week. Man, I'm pumped up. Tell me where you're at with your studies. I want to know. Let me see. We're up in part 5 right now. We're going over routing. And stuff like that. I got CML booted up in the background. You've been studying since May. Awesome. So, dude, you pump me up right now. Finished the OCG, did Wilson, feeling great. Amazing. That is awesome, man. Yeah, so like, do you have any plus I have like 5 years of experience. Do you really? See, that's one thing I wish I had. See, I'm brand new to all this. I started my journey back in August, and that's why it's kind of taken me a little bit longer to get me to the point where I'm shooting for February. So February, I'm shooting for the CCNA, and also right after that, I'm going to try to just shoot right to DevNet right after the CCNA cert. But let me see. What was my question for you? Like, where do you feel like? Do you have any areas where you kind of feel like you need a little bit more studying on, or are you like complete circle, like, man, like 100% on everything? My whole thing is I'm still crutched up with APIs. APIs are one area that's still. Yeah, exactly. So I got a sister. My sister works in the IT field, and she was the one that, like, kind of like pumped me up to doing stuff like this. My whole journey though started. I came across a David Bumble video, and David Bumble pumps me up, man. I love that guy. Yeah, wireless. Yep. I feel you on that one. Especially going over the channels, access points, and whatnot. I haven't quite so far got there yet. But that's one thing I can't wait to get into and whatnot. Yeah. So I mean, man, thank you for jumping on. Thank you for jumping and joining in. Like I said, I've told a couple times. I don't know if you've caught any of these before. But this is like the journey to the CCNA, baby. And we do a lot of reviewing here, and then then I'm gonna go over to CML. We're gonna do some configuration on the command line. This right here, we're gonna be labbing. I'm gonna pretty much build a quick lab with OSPF acting. We're going to build a backbone area 0 here. Yeah, yeah, yep, yep. I wish I can. Yeah. I mean, in Cisco Packet Tracer, that's where I'm gonna have to do a lot of my wireless lab, and obviously I can't emulate. Wireless tech, because then it'll just be making real wireless, and I'll be just messing with my own house at that point. So once we get to wireless, I got a Cisco Packet Tracer VM. Well, it's not a Cisco Packet Tracer VM. It's just a Windows VM that I got Cisco Packet Tracer living on. And when we get to the point where we're dealing with wireless, I got that ready. Raring to go, so we can lab up some hardcore wireless stuff. I've never used the Boson training stuff. I heard a lot of great stuff about that though. A lot of great stuff about the Boson training software. How do you feel? Like what was your what's your take on the Boson training software? Woo! I'm getting pumped up. I'm trying to swag down as much coffee as possible over here. Trying to get myself ready and raring to go. All right. All right. Good. They ask a lot of questions, not even mentioned in the OCG. Nice. Oh, did you really? When did you take the first exam? Did you? So, just a question. Um, well, that would be it right there. Ooh, dropping stuff. Are you consistently getting 90s now? Yeah. It was about a week or so ago, huh? No snap. And there was a lot. Yeah. So that kind of scares me. There's a lot of questions that I guess. So was it like it wasn't covered in the official cert guide? Is that pretty much what I'm gathering then? Um, like what? Like was it the wireless and the security part that kind of wasn't covered too deeply in the official cert guide? Is that where that's coming from? Where it wasn't covered too well in the official cert guide? All right. All right. Let's continue on. All right. Accessing the router CLI, accessing the routing command line interface. The CLI works much more like a switch. In fact, yeah, they asked about EGRP, which is not talked about in detail. Did they really go into EIGRP? I thought that would be like a topic like EGRP. That's a Cisco. Isn't that the Cisco proprietary? Wouldn't worry about it. I can pop back afterwards and take the test and give it a better assessment. The boson different material or not, different matter or not. Yeah, dude, just pop back in. Yeah, Oh, thank you for the follow. I appreciate that, my muffin. Thank you for the follow. You might earn some push-ups. Let's do some push-ups. Push-up times. My muffin earned himself some push-ups. It's push-up time, my muffin. Push-up time. Push-up time. Ooh, you get some push-ups for that one. Ooh, get some push-ups in. Oh, yeah. Ooh, get some push-ups. I gotta get back into shape, too. That's the other part. Get some push-ups for that one, muffin. Trying to get back into shape at the same time. Ah, yeah, dude, I bounce back, man. You pump me up that you're saying you shooting right back into it. Cause that's awesome, dude. That's for you, my muffin. For you. You pump me up right now. Um, Kudos to you though, man, for getting right back on the horse and getting back on it. Um, Kudos to you, man. Just my whole thing is like I just keep trying to lab. I have always felt that. Excuse me. I have always felt that if is just if I keep labbing and labbing and labbing and labbing and labbing, that it leaves like it like leaves physical imprints and allows me to like retain a lot of this knowledge. Uh, and what I've tried to tell a lot of people about the CCNA, because a lot of people question me about the CCNA, certain why I'm so vested into it and why it's taken me so long to prepare for it, is I tell people all the time like it covers a broad scope. It's not like it's like one thing. It's like it's a whole entire scope of networking in its complete entirety. I mean, you know what I'm saying? Oh, there's my awesome message. Um, but yeah, yeah, you know, again, we're trugging on, man. We're gonna get this cert, and then we're going after DevNet, man. What's your plans? Exactly. It's the only way. It's the only way. Just reading the book, I wouldn't. If I was just reading the book, I would not be able to retain any of this. Nope. It would just go right through my head and right back out the other way. Because it just wouldn't I guess it wouldn't make sense in a way. Like I couldn't put two and two together without labbing it. You know what I'm saying? Like why would I care to know what OSPF really does do if I don't create a lab and then I need OSPF to do what it does so I can route between multiple different areas. You know, if I didn't lab it, then I wouldn't know why that need or that service was, you know, created in the first place, uh, and like Ethernet channels, like why, again, if I didn't lab the purpose of Ethernet channels, did you do automation? I do automation at my previous and current. Do you really? Do you do? Is it mainly like Bash scripting type automation, or do you do stuff with Ansible or like Salt and Chef like that? Super curious, man. Super curious. I've done a lot of labbing with Ansible. I've just because exactly. Uh, but like I was saying, I've done quite some labbing with Ansible. I've even created Ansible labs inside of CML. I got Ansible labs. I got Ansible labs in a couple different areas, but I've never like let me see. I've never really messed with like Chef or Salt or anything like that. Um, do I have a? I wonder if I got a lab. Do I have my Ansible lab? Let me just log into my server real quick. wonder if I got my Ansible lab in my server too. I know I got a couple of Ansible labs. No, I don't think. I might have deleted my Ansible. Can always recreate another one, but yeah. Um, I love. That's I guess where I want to take from CCNA. That's why I'm going. I want to go straight to DevNet from CCNA, because of the automation. Because of at least what automation brings to the table, because it's the next logical step of where the technologies are going. You know what I'm saying? Virtualization and automation is the next step in networking. You know, Ansible, Python mostly, so some Go, GDP automation previously, provisioning devices, then had a custom tool on ongoing config, had some tools for reading some CFGs and some DSOM, adding them to way, which provide a bunch of API directions. Yeah, see, I need to get my API game up. That's one thing that I am like. That's one thing I guess I'm not. I really like. I gotta start playing with. And for sure, if you don't keep up with automation, you'll fall behind the industry. Exactly. I feel exactly the same way. The exact same way. But yeah, that's awesome, dude. That's awesome, man. See, I can't wait. I've been applying to IT, even like junior IT jobs. I've been applying to them like crazy. And they all obviously, hopefully once I get the CCNA cert, I'll be able to land even a junior position. But nobody wants to hire, obviously I can't get my foot in the door because they say, oh, you need X amount of, you need X amount of experience, you need X amount of experience, you need to know Cisco devices and everything. And I'm like, I emulate Cisco devices all the time. I can run the command line all day long on Cisco devices. Like, I create DHCP servers on my spare time. Just give me a chance. But I can't wait to get my foot in the door. Even at, like I said, even like a junior IT position, just so I can get hands on to just doing it for realsy and making it work in the real production world. You know what I'm saying? All right. Let's kind of get back to where we at. You pumped me up, Muffin. You just made my day. Hope you know that. You made my day, Muffin. All right. Accessing the router's command line interface works much like a switch. In fact, it works so much like accessing the Cisco's switch command line interface that this book relies on Chapter 4 instead of repeating the same details here. If the details for Chapter 4 are not fleshed out in your memory, you might be worthy to spend some time going back. Okay, cool. Yada yada yada. Cisco switches and routers share many of the same command line interface navigation features. What's up?
Mommy said she doesn't like Hershey.
Okay.
She doesn't like Hershey at all.
Don't eat the rest of those brownies though. Save them for her.
She doesn't like Hershey.
Save it, the brownies. Just leave it. All right. My kids want to eat all the. I made brownies for dinner tonight. Well, I didn't make brownies just for dinner, Matt. I made brownies for dessert. And they want to gobble them all up, so they're trying to make excuses now while Mommy's at work. Mommy doesn't like Hershey, remember, Daddy? So can we have the rest of the brownies? No, you can't have the rest of the brownies. Leave them for your mother. You've had enough brownies. So that was my little one he was trying to convince me that mommy doesn't like Hershey. Yeah, okay. Your mother's a chocolatite. All she does is eat chocolate. I'm pretty sure she's looking forward to gobbling down. You used to work at the Hershey Company. Funny to hear it. Right. Everybody loves Hershey chocolate. I don't know what that crazy little guy is talking about. I know what he's trying to do, though. You probably know what he's trying to do, too. All right. So some key topics. Yep, user enable mode. We already know that again from when we were talking about when we were reviewing the chapters previous and going over the how to access the switches, command line interface, enter and exit in configuration mode, configure a terminal and exit, same commands, accessing the console via telnet, via SSH, same type of configurations where the enable secrets, all right, encryption keys, login credentials, pretty much all the same as accessing how the switches were, all right. Configuring configurations of Ethernet interfaces that negotiate speed in duplex setting commands. Configurations of the interfaces to administratively disable shutdown and administratively enable the no shutdown. So same commands there. Configurations of interfaces to administratively disable. I just read that again. I'm reading it all over again because I forgot where I was. Navigation through the different configuration modes, context using commands like line console 0 and interface type number. All right. CLI help command. So obviously, like the same thing on a switch where you just simply put the question mark icon in and then press enter, and you would get a list of available commands. The meaning and use of the startup config in the NVRAM running config in the RAM. So same thing. So the configuration file is still all right. So your running config is still saved in the RAM. Your startup config file is still saved in NVRAM. So same thing as the switch. Okay. So when we're in the command line interface and we're making all these changes and we're doing all these cool configurations, that file, that text-based file, is sitting in RAM. We have to save that to NVRAM, just like when we did the switch. So then when we shut down the router and boot up the router, that file will get placed as with the boot up file to get our that same configuration back on that router again. So very cool. And external servers like TFTP, along with how to use the copy command and to copy configuration files and ISO images. All right, cool. At first glance, the list seems to cover most of everything you have read so far in this book about the command line interface. However, a couple of topics do work differently with the router command line interface as compared to a switch as follows. All right, so the configuration of the IP address differs in some ways where switches use VLAN, so the virtual local area network, so the virtual interfaces on the switches. So the switches, you typically assign the IP address to the VLAN, and then you assign the interface to the VLAN. That's how that interface would get that IP address, okay? Because you're assigning it to that virtual local area network, okay? All right. Many Cisco router models have an auxiliary port intended to be connected to external modems and phone lines to allow remote users to dial into the router and access the command line interface by making a phone call. Cisco switches do not have an auxiliary port. All right. Routers iOS defaults to disallow both telnet and SSH into the routers because of the typical router's default setting: transport import none. So remember, in our line configuration, modes, and we're in line, VTY or line configuration 0-215. That transportation mode, we can either transportation SSH, transportation telnet, transportation all, transportation telnet, and SSH. By default, the default mode is transport import none. So it's enabling both telnet and SSH, but you can still access it via the console. Okay. All right. Cisco's Catalyst LAN switches typically default to allow both telnet and SSH. Okay. All right. So it's basically the same. The topic on how to configure the both telnet and SSH process is the same process as that was covered in chapter 6 under the basic switch management. All right. And that's all that's staying there. All right. And it's just going over the same commands that we just talked about. Transport input telnet, transport input SSH, transport input all, or transport input telnet SSH. Okay. All right. The router's command line interface also differs from the switch command line interface just because the switch and routers do different things. For example, Cisco's layer 2 switches support the show MAC address table command. Okay, show MAC address table, while Cisco routers do not. Okay, remember, this is still, for instance, this is still talking about layer 2 switches. All right, layer 2 switches. All right, they're on the second level of the OSI model. All right, they're dealing with frames. All right, MAC addresses. Okay, where routers are on the very next level, the network level, dealing with packets. All right, IPv4, IPv6. Okay, that's what routers are taking care of. All right, layer 2 switches right here, routers right here. Okay, all right, that's all. That's all it's pretty much saying. So there's a handful of commands that are different. Okay, so there's probably more commands, but I'm just saying in general. All right, the show MAC address, because of its case where, again, layer 2, all right, would just be on a layer 2 switch, okay, where a Cisco router, the show IP route. Now, if we were talking about a layer 3 switch, which these images in here, so these switch images, okay, these are the iOS V2, if I'm saying that right. So yes, the iOS VL2, so that's the Cisco virtual switch image. All right, that's a layer 3 switch. All right, and that layer 3 switch does IP routing. Okay, layer 3 switches handle. That's why it's called a layer 3 switch, because it's also handling layer 3, which is packets IPv4, IPv6 routing, and you will have the show IPv routes and all that other stuff inside of those. You'll have those commands on a layer 3 switch. Okay, but again, this is just talking about layer 2 switches. Okay, all right. Cisco again, and it states that layer 2 switches. Okay, use the show interface status command to list one or more outputs per interface, and routers do not. While routers use the show IP, so the show IP interface brief command to show similar information, but switches do not. So layer 2 switches use the show interface status, while Cisco routers use the show IP interface brief. Okay, so just some nuances between a layer 2 switch and a Cisco router. All right. Note that some Cisco devices perform layer 2 switching and layer 3 routing. All right, and those devices support both routing and switch commands. Chapter 17, IP routing and LAN, discuss one such device, a layer 3 switch, in more detail. All right, so it even mentions there the layer 3 switch and how a layer 3 switch can handle both layer 2 and layer 3 type commands, okay, because it's handling both of those services. Okay, router interfaces. One minor difference between Cisco switches and routers is that the router supports a much wider variety of interfaces. Today, Local area network switches support Ethernet local area network interfaces on various speeds. Routers support a variety of other types of interfaces, including serial interfaces, cable TV, DSL, 3G, 4G, wireless, so your wireless home routers and stuff like that, and others not mentioned. So how it mentioned earlier, the small form factor ports, Ethernet. Routers support a wide array of varying type interfaces. Okay. All right. Most Cisco routers have at least one Ethernet interface of some type. Many of those Ethernet interfaces support multiple speed and auto negotiation. So for consistency, the router's iOS refers to these interfaces based on fastest speed. For example, a 10 megabyte per second only Ethernet interface would be configured with the interface Ethernet and then number. So interface Ethernet instead of interface gigabit. All right, it'd be interface Ethernet. You know what I'm saying? Because then you also have the interface fast Ethernet. Okay. Talking about 100 megabytes per second and then 1,000 megabytes a second, obviously be the interface gigabit in it. All right, and there you go, right there. That's all that, and then it says it right there, exactly what I just said. However, when discussing these interfaces all together, engineers can simply call them Ethernet interfaces, regardless of the maximum speed. Okay, some Cisco routers have serial interfaces, as you might recall from chapter 3. Cisco routers usually use interfaces to connect to a serial link. Woo! Might have to do some more push-ups in a minute. Each point-to-point or serial link can then use high-level data link control. So high-level data link control is that word again, HDLC, high-level data link control, HDLC. All right. The default, or PPP, point-to-point protocol. PPP, point-to-point protocol. You'll see PPP come up or HDLC come up when you're looking at some of the information on your packets. All right. Routers refer to interfaces in many commands. First by the type of interface, Ethernet, fast Ethernet, gigabit, serial, and so on. And then with a unique number of routers. And then with a unique number of that router. Depending on the router model, the interface number might be a single number, two numbers separated by a slash, or three numbers separated by slashes. Okay, for example, all three of the following configuration commands are correct on at least one of the Cisco models. Okay, so you have the gigabit Ethernet 0, gigabit fast Ethernet 0-1. So it's just showing you some of how you would do it. And then there's also some shorthand as well. You guys love seeing my shorthand that I tend to use with a lot of my commands. All right, and that'd just be like the interface E0 for the interface Ethernet 0 interface, or the INTG 0-0 for the interface gigabit 0-0 interface. Okay, so there's shorthand as well. Two of the most common commands to display the interfaces and their status is the show IP interface brief and show interface. All right. First of these commands list both one per interface with some information, including the interface IP address and the interface status. The second command lists the interface, but with a large amount of information per interface. The example shows each command. The output comes from the 2900 series ISR router used in many examples in this book. Note that it has both gigabit 0-0 interfaces and gigabit 0-1 interfaces, showing a case with both two digits in the third digit identifiers. Yeah. Okay. That was a mouthful right there. All right. Let's keep it moving. So here's just a show interface brief. So this is just an excerpt from an actual router right here. All right. Note commands that refer to the router's interface can be significant, shortened by terminating. You can never say that word. The words, and there you go. So it's just showing you that shorthand that you guys have seen me use 1,001 times. Also note that the show interface command lists a text interface description about the third line in its configuration. In this case, in the gigabit 0-1-0, had previously configured with the description as link in the lab to router R3. Yep. Interface status codes. So here's just some status codes. All right, line status. First status code refer to the layer 1 status. For example, is the cable installed? Is the cable right, wrong? All right, so the first status code refers to the layer 1. Remember, layer 1 is the physical layer, the actual link, so the actual connection, so the Ethernet connection. Is the cable actually in the actual device, okay? Second status code, referring generally to layer 2 status, so layer 2, okay? So that's how we can think about the status codes in layers. So first layer, my cable. Second layer, my layer 2, okay? Referring to the layer 2 status, and it is always down if the line status is down. If the line status is up, a protocol status of down is usually caused by a mismatch data link layer configuration. So if you had some mismatching somewhere, that's where that so that'll be the protocol status. Okay, so somewhere in your configuration you might have some kind of mismatch that's preventing that actual interface to coming up. All right, several combinations of interface status codes exist. As an example, in table 15.7, the table lists status codes in order from being disabled on purposes for the configuration to be fully working. Okay, so administratively down, layer 1, and then layer 2 down. The interface has a shutdown command. Shutdown command configured on it, so down. The interface is not shut down, but the physical layer 2 has a problem. So the interface is down, but the physical layer, so the actual link to the actual device, okay, there's a problem there. For example, no cable's been attached to the interface, or which the Ethernet, the switch interface on the other end of the cable is shut down, or the switch is powered off, or the device on the end of the cable has a different transmission speed. So that's just some of the codes right there that you'll see. Coffee. All right, and then we have up. All right, almost always refer to the data link problems, most often configurations. Always refer to the data link layer problem, most often configuration problems. For example, serial links have this combination when one router has configured to use PPP and the other device is using defaults to HDLC. So you'll get the up and down, and then the up, layer 1 and layer 2, and all this. Layer 1 and layer 2 of this interface are functional. All right. So, for example, look back, the show IP interface command on the 3 interfaces. Yep. All right. Router interface IP addressing. Cisco enterprise routers require at least some configurations beyond the default configuration before they will do their primary job, routing packets. Okay. The following facts tell us to make routing ready. To route IPv4 packets on an interface, you need to enable the interface and assign an IPv4 address. Most Cisco routers interfaces default to the disabled shutdown, okay, state, and should be enabled with the no shutdown. So remember, same thing like a switch, it has that shutdown, no shutdown command to bring that status to up or bring that status to down. Okay, all right. Cisco routers do not route IP packets interroute and interface until an IP address or and mask has been configured by default. No interface has been no interface has an IP. So it's just saying by default there is no default IP address or mask. It can't be. It doesn't. That wouldn't make sense. Okay. All right. Unless again, that'd be the, for instance, you buying or purchasing services from a internet service company that provides you a router. So they're gonna provide you a router, and all you may have to do is plug that router into that cable at your house, and wham bam, thank you ma'am, it starts working because that router has already been configured by the internet service provider, because they don't want people unknowledgeable just doing whatever with these routers. They're going to be the ones configuring that router for you and then just giving you that pre-configured router so you can just plug it into your Ethernet cable at your house and voila, you got internet. All right. So that'd be the, for instance, when that would take place. All right. Oh, all right. Push-up time, boys and girls. Push-up time. Here we go. Let's do it. Ooh, baby, baby. Ooh, time to wake up. Ooh, ooh, here we go. Getting into it. Ooh, yeah. Feeling the burn, baby. Feeling the burn. Getting pumped up. Getting pumped up. Get pumped up for you, Muffin. All right. Let's keep it going. All right. Let's get back to it. All right. All right. To configure the address and mask, simply use the IP address mask interface subcommand. All right. We'll go over that. Shows the simple IPv4. So the figure shows the simple IPv4 network addresses. So again, we have one. All right. So remember, let's get back to our. You're still watching, Muffin. You're the man. I love you. So again, let's get back to our thoughts about subnetting here. So we have, obviously we don't know the actual subnet here, but we're going to guess maybe it's the /24, or with it being given the 172.16, we could have the /16 mask, because if you remember, class full IP forward thinking, the 172/16 is a class B. All right, it's a class B network, so we could have by default the /16, giving us the our network then could reside there, or with it doing that. So this though is most likely a /24 network. Okay, so this right here would be the network 172.16.4. 172.16.5, 172.16.3, and that's why. So this would be 172.16.2 network with the /24 mask. Okay, same thing right here. Okay, so we have our routers configured with these multiple interfaces off here, and then these interfaces off of these routers for. So this is representing. These are representing our local area network. Okay, local area network. Local area network, okay? That's what these are, all right? And then this is our wide area network, okay? Wide area network here. And then this right here is some kind of, this would be like our corp main office here, all right? I'm just gathering that because of the server here. And that server is, again, probably servicing, these. I know it looks like all scribbles now because it is all scribbles now. So this server here is probably, again, it's doing some service for these areas over here. All right. So that's, they're in different networks. They're in different networks. All right. All right. These are their own local area networks. This is its own local area network. These are wide area networks, all right? but these interfaces, all right, and then you'll have like a routing protocol, you know, OSPF, EIGRP, or possibly BGP, but I doubt BGP. It'd be more like, again, it could be, given that there's a cloud here and this is a serial line, it could be BGP, because this could be representing the big wide internet, and what routes the big wide internet is BGP. All right, and then obviously you'll have, yeah. All right, let's move on from there. I know we haven't got that far yet with our studies yet, but just bringing that up as a note. All right. So here's a code insert of configuring the command line, of configuring a actual interface of that router. So again, we have the IP address command, followed by the address, followed by the subnet mask, okay? Or the mask, or whatever you have to call it. So this is the command. This is the actual IP address, okay? And then this is your subnet, all right? All right? Then you have to always, because by default, on a Cisco iOS, on a router, your interfaces are they're on the administratively shut down mode. So you have to administratively bring these interfaces up, and you do that by giving them the no shutdown command. Okay. Now you can move, and I've talked about this before. You can move. You don't have to go back to say like the global configuration mode to move into another interface. You can move between interface to interface to interface to interface, all right, from each interface's sub-command area, okay? Again, you just have to type it out correctly, all right? You may not get like context-sensitive help when you're in these sub-command areas for that. So it's not like you can just write, you can't just tab it out and it to complete for you. But as long as you spell it all out right and you have it right, you can then move into each interface from each interface, okay? So again, it's just a code insert from some kind of router, all right? And then the next insert here shows the output of a show protocol command. This command confirms that the state of each of the three routers interfaces, the IP addresses and mask configured on those. Okay, so here's that show protocol command. So the show protocol command, all right, it's telling us our interfaces they're up. All right, the IP address is 172.16.1.1/24. All right, so that's the 255.255.255.0. All right, that's all that's representing. Same thing, serial and gigabit Ethernet. Okay, all right. One of the first actions to take to verify whether a router is working is to find the interface. Check the interface status and check to see whether the correct IP address and mask are used. Shows an example of the show commands. Summarizes. So we have some show commands. Show the show interface brief. All right, number of lines, addresses. Show protocols. That's going to show you addresses and masks. So the show interface brief command is going to show you addresses. Okay. Show interface, and then the actual interface number. The teaching is good if you can explain it to someone else, then you probably know the subject very well. Thank you very much, Muffin. I appreciate that. That's a, thank you, man. So that's like super. That's been like super important about why I generally. That's like the main reason why I actually started this stream, because of that actual purpose was, if I can explain what this is, if I can explain these subjects to somebody, not only is that reinforcing that into my own head, it's forcing me. It's like I gotta force myself to really know this stuff, so I don't come off, I don't come off like I'm just reading the book. You know what I'm saying? I don't want to just read this to you guys. That would be wrong of me to do. All right, that would be an actual wrong thing for me to do if I was to just sit here and read this book. I want to be able to explain the information that I am pulling from this book, because I want to pull this out and I want to regurgitate it to you guys, to my audience, to you, to anybody else who's watching, in a way that I see it as. You know what I'm saying? And because when I pull it out and I push it back, it's like it's reinforcing that knowledge back onto me, and like again, it's just imprinting it more and more in my own head. Yeah, so that was like a super important part, again, why I decided to do this stream. There's other reasons too. There's the reason I want to, if I can explain this to somebody in a way that if they're struggling with a particular subject or a particular topic, if I can explain a certain topic that they might have not been able to grasp, and maybe if I can do it in a way that they could catch it in, that right there would be so awesome for me. That would be the prize. You know what I'm saying? That would make me feel so good. And also, if I could spike the interest in somebody to maybe start studying for their CCNA cert, to change their life, to take it upon themselves, to challenge themselves to do this cert, that again would make this stream worth everything that I hope it's going to be worth. You know what I'm saying? Because that's what I've found in this whole CCNA network and Cisco thing is, everybody just wants to help everybody learn this stuff, man. It's like the whole community is just revolved around helping others learn these technologies. And it seems like that's the whole motto behind all of this, is this, let's learn this together. That just seems like to be what it's all about. And that's what I'm hoping at least to capture, by doing, a stream like this. You know what I'm saying? Thank you so much. I appreciate that, man. That's awesome. Thank you. All right. More coffee. Coffee. All right. Let's continue on. Let's make the push, baby. All right. Bandwidth and clock rate on serial interfaces. Cisco also has included serial WAN wide area network topics in the CCNA exam topic list since its inception in 1998 until the CCNA 200-301 released in 2019. Because of the CCNA 200-301 exam is the first not to mention serial technologies at all. This book includes some examples. That show serial links. The exam might show them with expectations that you at least understand basics, such as the fact that two routers can send data over a serial link if the router's interface on both ends are up, and the routers have an IP address in the same subnet. However, some of you will want to make serial link work in labs because you have some serial link interface cards in your lab. If so, take the time to look at a few pages in the bandwidth and clock rate and the Appendix J. Yep. All right. Router auxiliary ports. Both routers and switches have a couple ports to allow administrative access. Both Cisco routers have an external physical port called auxiliary port. The auxiliary port typically serves as means to make phone calls, to connect into the router, to issue commands on the command line interface. The aux port works like a console port, except that the aux port is typically connected through a cable to an external analog modem, which in turn connects to a phone line. Then the engineer uses a PC or terminal emulator in the modem to call the remote router. After being connected, the engineer can use the terminal emulator to access the router's command line interface, starting in the user mode as usual. All right. Auxiliary ports can be configured beginning with the line auxiliary 0. All right. So that's when you'll see the line aux 0 command. All right, in the global configuration. All right, that you'll see that. All right, so that's what that's representing. All right. Command to reach the auxiliary line configuration mode. From there, all commands, all the commands from the console line covered mostly in Chapter 6 can be used. For examples, login and password subcommands on the auxiliary line can be used to set up simple password by checking when the user dials in. All right. So here's just some stuff to review and setup steps required to install a router, similarities between the router's interface and the switch's interface, items covered for switches in the Chapter 4 that differ from the routers, router interface status codes and their meanings, combinations of two interfaces status codes, and the likely reason for each combination. Commands useful to display interface IPv4 addressing mask and interface. Some key terms should note: enterprise routers, SOHO routers, integrated service routers. All right. And then we just have some command lines: interface, IP address, shutdown, no shutdown, duplex, full, half, auto, speed, 10, 100, and 1000. And then just the descript. You guys have seen me use the descript a lot. Just to throw a little description on the actual interface themselves. All right. Then we have our show interface with the number. So it'd be like show interface gigabit 0-1 or gigabit or fast Ethernet or Ethernet dash whatever. So we have the show IP interface brief, and then the show protocol, and then the type name. Okay. So that covers Chapter 15. All right. Now what I guess we'll do. Let's jump right into Chapter 16 now, because again, I want to make a hard push to get us through Chapter 5. All right, in Chapter 5 again, let me go over my big book here. All right, so Chapter 5 again. Chapter 5 again, so we're going to be covering Chapter 16. That's going to be obviously where we're at now, configuring IPv4 addressing and static routes. Chapter 17, IP routing in LAN in the local area network. And then Chapter 18, troubleshooting IPv4 routing. Okay, so we have Chapter 16, Chapter 17, and Chapter 18 to go through. And honestly, these are pretty straight through chapters, guys. We're going to be talking about, so it looks like in Chapter 17, that's where we're going to start talking about sub interfaces on the actual routers. That's how we're going to get into that lab that we're going to make at CML. So we might as well, let's get some commands going in that lab that we already got booted up right now. And let's start making some links, and let's get this lab roasting. Let's roast up this lab. Okay, let's start off. Where do we want to start? Let's start off with this router right here. Let's see how that looks. See if that's zoomed in enough for you guys can see a little bit better on the command line itself. Yeah, you can see pretty well. All right. So what we need to do, let me go back here. We need to do like some kind of like a plan on how we want to do some of our routing plan here. All right, let's do this. So let's do some routing plans. So let's just say area 0. Area 0 is going to be 10.0.0. Okay, so that's going to be area 0. All right, so we'll say this link over here is going to be 10.0. Yeah, we'll just say 10.0. 10.0.1. Yeah, that'd be cool. We'll keep it simple. We'll keep it simple, and we'll give it the slash. Because we got 1, 2, 3, 4. Yeah, we'll give it the slash 30 maps. There we go. We'll get 4 IP addresses out of it. And then we'll be good. Right? Yeah, we'll be good. So the 10.0.0.2, 10.0.0.3, and then 10.0.0.4. Perfect sauce to save the day. All right, so that'd be that. And then we'll get all of that area. So we'll make area 0 the 10 dot network, okay? And then this interface going to this network, okay? So this would be the 192.168 dot we'll say 0-1 for this interface right here. All right, and then we'll have this switch. We'll have it as 3 VLANs. Okay, we won't assign any IP addresses to this switch because we're going to have it as acting as a layer 2 switch only for now. Okay, and then we'll have it dynamically addresses areas. So this would be the 192.168.10 area, 192.168.20 area, and then 192.168.30 area. Okay, and then this interface over here would be 172.16.0.0. All right, we'll say 0.1. All right, very good. You know what? I'll even change. Yeah, that's fine. That's fine. And then this switch will just have one VLAN and be VLAN 100. So it'll be 172.16.100. All right, that'd be that area, and that'd pretty much be our sweet and simple routing plan. Yeah, that's cool. That's cool. That's cool. What do you think, Muffs? You think that'd be cool? Think that's good enough? I think that's good enough. All right, let's get into it. Let's get into it. All right, let me move this back to the zoomy, and then actually let's make some connections here. Connections, yeah. 0, and we'll say 1 to 1. We'll say 1 to 1. Whatever. And then, yeah. Yeah. Very good. That's it. That's it. Very good, very good, very good. All right. All right. We're in it to win it now, boyzos. All right, so gigabit 0 and 1. Oh, very good. Okay. Console, and it broke again. There it goes. Okay. All right. Move into enable mode. Configuration terminal mode. All right. Interface. Gigabit 0-0. All right. We're going to say IP address 10.0.0.1. All right, 25.25.25.252. All right, very good. We got the no shut. And description. All right, we're gonna say link to area 2. Cool. All right. Interface gigabit 0-1. IP address 10.0.0.2/25.25.25.252. Very good. Hold on. No, I'll do this now. Interface gigabit. Oh, I know why. I know why. Alright, that's fine. 10.0 interface address 10.0.1 1 dash 5.2.5.252. No shot. Description. Link. That's going to area 2 now, right? Link to area 1. All right. Then let's go into interface, loop back. 0. The address 1.1.1.1 5.5.5. All right, let's exit. And let's do a little bit of a router. OSPF. And I'm going to say network 10.0.0.0 0.5.5.0. Then let's do this. That's all set now. IP, DHCP, pool, area 1. Let's say network 10.0.1.0.25.5.5.2. And we're going to say default 1. That's 10.0.1.1. Lease. Infinite. That's it. DHCP. Pool. Say area 2. Work. 10.0.0.0 5.5.5.2. Yep. Yep. All right. Let's say default 1 and DNS 1. Lease. Infinite. Right. Exit. Let's write that configuration real quick. All right. Let me just do a douche. Let me just look at it real quick, make sure it looks good. Area 1, area 2. Yep. Mm-hmm. All right, that's good. All right. Let's do this. Yeah. D. Base. Where am I going? These new bases. So, same thing. Yep. Top breaking Cisco. Base gigabit 0.0. IP address. Yeah, that's fine. We're going to say 10.0.0.2. That should be fine. 2.5.2.5.2.5.2. Shut. Description. Link to 2. Right in the face. Bit 0.1. IP address, and then we're gonna say, you know what I need to do? Yeah. IP, DHCP, exclude 10.0.0 to 10.0.0.2. Let's say, because we're going to get 4 IP addresses out of this. That's fine. We'll have it, just exclude those. And then 1. And I'm going to give this the 10.1.2. 2. Got. Okay. Okay, description. Link to 2. Okay. 0. P address. 2.2.2.2. Shut. Exit. Let's just write that real quick. That writes. Okay. Now let's do router. OSPF. 1. Network. 10.0.0.0. 0.25.25.0. It's not going to make an adjacency just yet. Is it? DHCP. Cool. There we go. One. There we get one. That's going to be network. 10.0.1.0. 2. Default. I'm going to say 10.0.0. 10.1.2. I'm making it overly complicated, yes, I know. But all because I want to see if this will work today. It would have been easier if I didn't include the 2 routers, but I am. Just because I want to see what OSPF is going to do. DHCP. Cool. 2. Network. 0. 2. Default. 10.0.2. DNS. 10.0.0.2. Infinite. It. Say IP DHCP. Exclude. Say 10.0.0.0 to 10.0.0.3. That way it gives out that last address. Same thing with this one. Let me just do a do show run real quick. Let's see what I did. Good. Good. Yeah. That is what interface is going to this first router. Let's see what that should. Yeah. Comfort. Interface. Gigabit 0-0. IP address. DHCP. Chat. Description. Two. Maybe should have made that range a little bit bigger, but come on, baby. Can't get an IP address today? No big deal. I might just need to make that range bigger. I can make it to 248. Let's do that. Yeah, I don't know if I made an IP address the way I did that. Let's see if, let's go to this then. Gigabit 0-1. Interface. Gigabit 0-1. Sure. Gigabit 0-1. Alright. IP. Address. TCP. No chat. I might have overcomplicated it. I probably did. Alright, interface, loop back. 0, IP address, 3.3.3.3, 5, that, exit, OSPF, version 1, network, 0.0.0, 0.25.5, area 0. Yeah, alright, exit. Alright. No big deal. Let's come back over here. Let's just make that range a little bit bigger. Interface. Gigabit 0.0. Say no. So what did I do that? Gigabit 0.0. No. IP. Address. 10.0.0.1. 5. 2. 8 instead this time. Chat. Face. 1. P. 1. 2. 8. Exit. Copy. Paste. No. Network. 10.0.0.0. 5. 2. 4.8 instead. Enter. Exit. Paste. And then 0, 2, 4, 8. Show. Right, yeah, adjacencies. Fix that problem. All right. So that's a done. Now I gotta fix this one. And the links going to that is 0 and 1, same thing. Base gigabit 0.0. And you know what we're gonna do? We're gonna do a little bit different. This. What did I give this one? E. Paste. We'll do something different. This 0 dot. Since this is area 0-2, it's a 0-1 on this one. 5, 5, 5.248. Okay. That's good. Interface gigabit 0-1 normal IP address. This one. Two. Yeah. Oh, wait. This one. B. Paste. So now we're going to give it the IP address of something different, 10.10.3-1. Good. Okay. Exit. Let's fix the DHCP again. So IP. Let's go. Made. Let's fix area 2 first. Paste. Paste. No network. 0-555.2. And we're gonna say network, because that's now the 2.network. Yep. 10.0.0.2.25.8. No default. No default router 10.0. 30 managers adjacency. I'm gonna have to shut that line down and bring it back up. It's okay. 2.1. All right. Set that 0.1 dot. What did I make that? I'm getting confused now. 1.2. Okay. Okay. That's it. Let me just look at that configuration real quick. That's what interface is going to area 2, 0-1. 0-1. Shut down. Shut down. Good. Still gotta fix that one. It's fine with me. I fixed those. Now I just have to fix that other DHCP pool. And other than that, we should be back up and running and rocking and rolling. All right, we've made our adjacencies. Yeah, so we do a show. We do a do show IP routes now. We already got our couple networks in there already from OSPF. Very good. Very very good. Very good. So now we can ping this router and we can ping that one. I just have to fix that other DHCP pool and then we'll be good to go. So this one. Copy. Paste. Copy. It's going to be, what is that, 3.1 now, right? Yeah. All right, so network 10.0.3.0.5.5.5.8. No default router. 2, right? That's what I had in there first originally. Yeah, 1.2. 1.2. It's 10.0.1.2. Let's say default router now 10.0.3.1. Very good. Okay. We should be back on track. We should be back on track, yeah. And this one should be simple, easy now. Let's get into this one. Okay, interface. 0.0, IP address, DHCP. Oh shit. Okay. Alright. 1, IP address, DHCP. No shot. Okay. Interface, move back. 0, IP address. 4.4.4. 2.5.2.5.2.5. Okay. Zip. Go into router OSPF 1 work 0.5 0 zip. And we're making all of our adjacencies. Very good. All right. That covers that then. And let's do a do show IP routes. Okay. Have all of our routes now. That's good. That is good. Now let's move into what we're going to be doing into this area now. So interface, grid 0-2, 192.168.0.1, 2.5.5.0. No shot. All right. Now let's move into interface gigabit 0-2.1 incap.q -1. Okay, IP address 2.168.1.255.0. Shut. Alright, interface gigabit 0-2. No, interface gigabit 0-2.10. Encap Q 10 the address 2.168.10.1.25.25.0. Shut. Okay, interface gigabit 220 cap Q 20 the address 2.168.20.1.5.0. Shut. Interface gigabit 0-2.3 cap Q 30 the address 192.168.30.1.255.0. Right, get out of there. P pool 10. We're gonna say 2.168.10.025.5.0 default router 2.168.10.1. That's 2.168.1. Lease infinite. Alright. That's it. P DHCP. Pool 20 network 2.168 0 2.5.2.5.0 default 2.1 that's 2.1 it's infinite. That's it. VLAN 30 work 2.168.30.025.5.0 default 2.168.1 that's 2.168.30.1. Alright, that's it. Let's take a look at that one now. That one should be good. What I think I need to do, yes, so this is what I need to do. Make this work though. Is let's go back to I might have to do this on every single sub interface, but let's see. Interface gigabit 0-2. I'm gonna say IP OSPF area OSPF say area 1 Then interface, give it to dash 2.1. Say that is area. We're just gonna call it area. We'll call that area 11, even though that's that. And then interface gigabit dash 2.10 area 10 base gigabit dash 2.20 base gigabit dash 2.30. So, if I'm not mistaken, this should work. Exit. Right. Just want to take a look at this configuration real quick. You shall run. We have our sub interfaces, and we have our OSPF areas. Now, make sure this all works. Just do this real quick. Just change that stinking host name to switch. All right. We're just gonna make a VLAN 10. Whatever name, we're gonna call you VLAN 10. Okay. Now we're gonna make a VLAN 20. VLAN 20. 30. Int. Maybe VLAN 30. Dash 0. Switchboard. Okay. Q. Switchboard. Trunk. Okay, good. Drop this down just a little bit. 1, 2, 3, good. One, switchboard. Access 10. 2. Switchboard access 20. 3. Switchboard access 30. Alright, exit. Right. Alright, this should get us up and running now. Should get addressed. Alright. Do show interface. All right, we got our trunk up and running. Woo, woo, woo. All right. So what should happen is now if I go over to this router, yes. All right. So look at that. We have our areas. Look at that. Perfect. Woo, 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 woo. All right. So these now. Cisco. These should have IP addresses. Yes, they do. And they should be able to ping. Yes, they can ping the Airbnb routers. All right. That's good. Got that done. All right, sweet deal. Let me just run to the bathroom real quick, guys.
Mommy doesn't like Hershey. She doesn't like Hershey.
All right. So, all right. So that's good. That configured right. And then again, everything should have gotten. I don't know what password. Yep. Perfect. All right. Everything's addressed in the right zones. Now we come over to here to this router. Right. Two. Address. 72.16. 16.0.1. 0. Shot. Right. Interface. Gigabit 0-2.1 address Q1 native address 172.16.1 5. 0. Yeah, that's fine. This, yeah, so let's just, from here, let's just do the IP. SPF. I should have went back to the other one. Area. I'm going to call this area 1. Area 1, right? I guess it doesn't matter. It don't matter. All right. And then I just go back and do it cell. It's F1 area. And interface gigabit 2.100 and Q 100 address 72.180.1. Okay. Yeah. 1 zip GP pool 100 72.180.0 1 DNS 172. Exit. And I think that's it. Okay, switch that. So let's just move an interface gigabit 0-0. Let's say switch port trunk encapsulation Q. Switch port old trunk exit. $100. Okay. Let's just move it to interface. 1 now. Switch port access. Okay. That's it. Right. Anything. That again. See if we picked up those new areas now. Yes, we did. Woo! Baby, we did it. All right. All right. Up real quick. Yes. Okay. Let's ping one of these guys. 168.10.2. Yes, we did it. Captain, we did it. All right. That is amazing. All right. I know I kind of like picked myself up in the beginning of it, but essentially, what we created was a area, obviously, with some area routers and everything else, some area 0 routers. And then if you look at these routers now, they're routing tables. Their routing tables now are full up of all the actual areas, pretty much that are now OSPF is. So OSPF off of this router is addressing. It's advertising. It's advertising these areas. All right. It's advertising. It's pretty much saying to all the other routers, like, hey, listen, I have these couple areas residing off of one of my interfaces here. All right, even though these are sub interfaces, it's still advertising them. Same thing with this router. This router is advertising a whole bunch of areas now to all the other routers here. And same thing here. If we run, all these routers should have the same. Show routes. That is a sweet table right there. So if you look at these now, this has its table pretty much full up of all the routes that are available to be connected. So what you're seeing with these IAs, those are those routes that are being, again, advertised by this router over here. All right. You're seeing, again, OSPF is picking up for this router, and then you have the sub interfaces. That's what you're seeing, some of these right over here. So again, if we go over to this router right here, to show IP route. All right, so again, we have a nice full up routing table, again, showing us some OSPF. All right, some OSPF information, some more OSPF information, telling us about these routers over here. And then it's showing us the advertising, those routes that are being advertised by this router over here. Again, even those are sub interface routers, sub interfaces off that router. It's still, again, picking them up as different, as being routes advertised off of that router. But that, again, it was pretty neat when I labbed that up the other night. I know it's kind of like a quick and dirty. It was a quick and dirty lab. Yeah, I love doing this type of. I just love labbing. I had to breeze through it real fast too. yeah, I mean, within, what did that take me? About a half hour, 45 minutes to lab that up, to wing it. Was winging it all, coming up with all the subnets and everything else. Now, obviously, if I had some more time and thought about like maybe the subnetting plan and all that stuff, I could be more mindful about how I was laying out the subnet plan and whatnot, and how maybe we addressed everything a little bit more tighter, so we weren't wasting addresses or anything like that. You know what I'm saying? And again, I kind of biffed it in the beginning of it. But no, it came together. Fast. And like I said, we should have addresses on everything now. Yeah, so everything's dynamically addressed. 168.30. Is that true? That. 168.30.2. I like it a lot. A lot. All right, so that's pretty much the lab now. How much time we got? So I got about a half hour left. All right, so let's go over chapter 16 then. I know I kind of pushed through that lab fast, but if you guys have any questions for me, just ask questions at any time, and we could kind of talk about things. All right, configuring IPv4 addresses and static routes. Configuring IPv4 addresses and subnetting. Interpret the component of route tables, routing protocol codes, prefix, net, network mask, next hop, administrative distance, metric, gateway of last resort, determining how a router makes a forward decision by default, longest path, administrative distance, configuring the and verifying IPv4 and IPv6 static routes, default routes, network routes, host routes, floating static. Routers route IPv4 packets. The simple statement actually carries a lot of hidden meaning. For routers to route packets, routers follow a routing process. The routing process relies on information called IP routes. Each IP route lists the destination, an IP network, IP subnet, and some other group of addresses. Each route also lists instructions to tell the router where to forward the packet sent to the address in the IP or subnet. For the router to do its job, to do a good job of routing packets, the router needs to have a detailed, accurate list of IP routes. Routers use three methods to add IPv4 routes to their IPv4 routing tables. Routers first learn connected routes. So that's like when you saw everything making its adjacency. All right. Which are routes for subnets attached to the router's interface. Routers can also use static routes, which are routes created through a configuration command that tells the router what the route to put the IPv4 routing table. And routers can use a routing protocol in which routers tell each other about. It's gonna be push-up time again. Every time, I swear. When I'm not labbing, I get tired. You know, it's funny. I got to work the overnight shift tonight. That's what I get for not sleeping that much today. All right, let's do some more push-ups real quick. I got to get fired up. Make the last push. Ugh. Let's make the last push. Make it work. Ready? Let's get some good form.
Good placement. Ooh. It's for you, everybody. Oh, yeah. Pushing the earth, baby. I'm not doing push-ups. I'm just pushing the earth. Can you feel me? I'm pushing the earth. All right.
All right. Yeah, it wakes me up every time. Gives me like a punch of energy real quick. All right. Routers use three methods to add IP routes to the IPv4 routing tables. Routers first learn connected routes, which are routes for subnets attached to a router's interface. Routers can also use static routes, which are routes created through a configuration command IP route that tells routers to route to put the IPv4 routing table. All routers can use a routing protocol in which routers tell each other about all the known routes. So then all routers can learn and build routes to all network and subnets. This chapter examines IP routing in depth, with the more straightforward route that can be added to a routing table. The router starts with the detailed look at the IP packet routing forwarding process, and a process that relies on each routing having a useful IP route and their routing table. The second section then examines connected routes, which are routes to subnets that exist on the interface connected to a local router. The third section then examines static routes, which are routes the network engineer configures directly. The chapter ends with a section that looks more specifically at the IP routing process in a router, how it matches packets to the routing table, and how to interpret all the details in the output of the show IP route command. All right. Let's keep it moving, and let's hit this real hard. Let me clear that up. All right. Router R1 lists a route in its routing table. Which of the following answers list a fact from a route that the router uses when matching the packet destination? All right, packet destination. All right. Which of the following answers list a fact from a route that the router uses when matching the packet destination? All right. Asking subnet ID. I wonder. But, I mean, which of the following answers list facts about a route from which of the facts from a route that a router uses when matching the packet destination? So B, maybe. I'm gonna say B. I want to say increase that size. 1. Let's say B. And I don't know if they call it mask or subnet ID or outgoing interface. Let's go with C, B and C. All right. After configuring a working router interface with IP address and mask. Hey, baby. Oh, are you? Okay. All right. So you got a little bit early. All right. Thank you, baby. Yeah. All right. Mom. I love you too, baby. I'll see you when you get home. Bye. Sorry, guys. My wife just called me to tell me she's getting out of work. That's it. How's everybody doing up in the Chisette, huh? Hope you guys are doing good. Oh, look at that. I got a couple of likes on mine so far. No comments. Just update that real quick. There we go. All right. All right. So after configuring a working router interface with IP address and mask 10.1.1.100-26, which of the following routes would you expect to see in the output of the show IP route command? Choose two. So that would be so /26. We're looking at 192. So we're looking right here. And yeah, so if we were to actually go back to CML, let's take a look at that. It's broken here. So we'll take, for instance, like that route right here. So you'll see how it has the subnet mask that we gave it, but then it also has the like the broadcast address of what it would be. So connected, and then local. So connected would be the actual address, and then the local would be so the connected. So this would be, where is it? So let me just do the math on that. So 255.5.192, and then our address is 10.1.100. The broadcast would be 192 minus 256. 192 minus 256. $64. So 64 would be the subnet ID. And the broadcast would be 127. All right, so let's go with A and D. We're going to say 2, A and D. I'm going to say A and D on that one. All right. An engineer configures a static IPv4 route on router R1. Which of the following pieces of information should not be listed as a parameter in the configuration command that creates this static IPv4 route? An engineer configures in a static IPv4 route on router R1. Which of the following pieces of information should not be listed as a parameter in the configuration command that creates this static IPv4 route? The destination IPv4 subnet ID, the next hot address, IP address, the next hot address neighborhood interface. Static which of the following pieces of information should not be listed in the parameters in configuration command that creates the static route? Oh, what is this question asked? Which of the following commands correctly? The subnet mask, the next hot router neighboring interface, D. Let's look at CML again. So let's go with A. 3 would be A. We're just gonna say A. Which of the following commands correctly configures a static route? IP route, yeah. I can't use the thingy. Let's go here. IP route. I'm gonna say 10 dot whatever. I'm gonna scratch my head on this one, huh? I was gonna say B. A network engineer configures route, IP route out of that command on a router. Or I just said it right there, so B's right. And then issues the show IP route command in enable mode. No route for subnet. Appears on the output. Which of the following could be true? The IP route command has an incorrect index and rejected in config mode. Interface is down. The router has no up on the interface. Class A network. IP route command is missing. Next hop router IP address. Oh, I'm actually wrong, ain't I? I am wrong. It's A. 4 is A. Four is A. 5. 5. 5 is D. A router lists out its interface. Which interface will the router's packet destination IP address to the 10.15.122. Let's do the math on that one real quick. have 5, 5, 5. That's 54, 10, 1, 15, 6, 54. 256 minus 224 equals 32. 96 divided by 32 equals 3. 3 times 52 equals that, plus 32, 128. 128. So it would be gigabit 0, so it'd be D. All right, see what we got wrong, see what we got right. So I got, this is A, this one, got that right, got that wrong, this is C, I got that right, this is wrong, this is B, and I got that right. Okay. Let's take a look at what we got wrong. Mask, what did I say? Next hop and submit ID. All right, so it's saying mask. And outgoing interface. Okay. All right. So just terminology was wrong on that one. I got that one right. And 3 is C. The next hop route is neighboring interface. Okay. And then B. And then B. So the interface was actually down. Okay. All right. All right. All right. So it looks like we have some more reviewing to do on this chapter. It looks like we really are going to have to spend some time on this chapter to really get down the idea here. So, get this lab shut down though. I hope I saved everything on that lab. But this has been a good lab today though, guys. Hope you guys got something out of today. Like always. And I hope to see everybody back again tomorrow. And again, we're going to be picking up right at chapter 16, even though I wanted to make the hard push to get through chapter 16. Didn't look like we were going to be able to. That's okay. You know what I'm saying? Music. That's what this is all about. This is all about learning, guys, and again, like I've said from the beginning, guys, I'm learning this. I'm on my venture to learning all this cool stuff. I'm taking you guys along with me on this journey. But yeah, like I said, like I always tell you guys, I hope you guys had a good time with me tonight, and I hope you guys learned something. I will see you guys back here again tomorrow, 5 o'clock Standard Eastern Time. We'll be back on hitting the books hard, studying like champions, like we are. We are champions here. All right, and yeah, I want to tell you guys I appreciate your time as always, and I hope you guys have a great night, and I'll see you guys back here tomorrow. So thank you very much, guys. I love you guys. Have a good night. Have a good night. All right, everybody. Take it easy. Go slow and be